Hello everyone, welcome to this chapter. In this chapter, we are going to talk about how to configure and troubleshoot end devices in Cisco Packet Tracer. We are going to connect end devices to hubs and switches and configure end devices and troubleshoot the connectivity. In Packet Tracer, as you can see, we have end devices exactly here. So if you click here, we have end devices like PC, laptop, server, printer, IP phone. Just for now, we click on this icon and this icon, and we need 4 end devices because we should configure 2 different networks, 2 different subnets. And if you click on this icon, network devices, and you can see that we have routers, switches, and hubs. We click on hubs, and from here we select the hub device and another one for these 2 devices, and click on this icon for the switches and select 2960 Cisco switch to connect the hub devices together. Okay, now for the connections, if you click here, we have different connections. We have the console. We will talk about the console later. We have copper straight through and crossover. If we have different devices like switches, hubs, and end devices like PC, if we connect different devices together, we need different copper cables or UTP cables in real environments. But in Packet Tracer, we can select automatically choose connection type like this and connect the PC to hub device like this. But in real environments, obviously you should know we have to use Cat5 or Cat6 or Cat7 cables, UTP cables to connect the devices. So we can connect the end devices like this and hub devices to the switch like this. Okay, now from the tools here, I select this one, subnet A here, and another subnet which is subnet B here. Okay, now we can save the configuration from the menu, and after that we can start the configurations. If you don't want to do these steps, you can just go to this link and go to github.com/nemax, and here we have a repository, Udemy Cisco Packet Tracer Network Administration CCNA Lab, and click here. Or if you go to the username from repositories, you can see the Udemy Cisco Packet Tracer Network Admin CCNA Lab, and click here. And because this course is part 1, go to part 1 so that we have the information related to the Packet Tracer installation, the Network Academy, the URL link to the Network Academy, and the Packet Tracer installation and everything. But this chapter is chapter 2, so you can download the lab template packet tracer file and open the packet tracer and do the rest of the configurations and everything. We have the lab file and the commands and the notes and tips and tricks. So if you want to download the Cisco packet tracer, you can get all of the files from here. Download the zip file. If you click, you can get the zip file and you have all of the files, the packet tracer and all of the notes and files. In this chapter, we are going to talk about the connectivity and configure the end devices, the IP address for both end devices in subnet A, which is the range of 192.168.11.0 with this subnet mask, and subnet B, which is 192.168.13.0. After configuration, we should check the connectivity. We should know how to check the connectivity and the commands. And for the subnet A, the devices should have the connectivity with each other, and obviously for the subnet B, and check the configurations on the end devices, and check the MAC address table on the switch, and obviously clear ARP cache on end devices. So before configuring the end devices and troubleshooting, let's talk about the end devices, connectivity, the switches, and the hub devices. Okay, now, how to configure and troubleshoot end devices in Cisco Packet Tracer. What are the end devices? You know that end devices are computers, PCs, laptops, smartphones, servers, printers, IP cameras, VoIP phones, and any kind of devices that we configure IP addresses and subnet mask and gateways. And to connect the end devices to the hubs or switches, we use UTP cables. That the UTP cables are unshielded twisted pair cables, and obviously sometimes we connect the switches together using fiber optic cables, but we will talk about the fiber optic cables and the connectivity between the switches later. But just for now, we should know that the cables, the UTP cables, are the cables that we connect the hub devices together, the end devices to the switches, and like that. So we have different categories: Cat 5, Cat 6, Cat 7 kind of cables, and the connectors for these kind of cables are RJ45 cables. We should know about the standard, the connectors, and the difference between the cables and the category and the transfer rate, because for the Cat 5e it can support up to 1 gigabit per second. For Cat 6 and 7 it can support up to 10 gigabit per second. For the interview and the exam, we should know about these kind of information. UTP cable should be less than 100 meters. We should know about the advantages and disadvantages. You can get more information from here. What about the hub devices? Obviously, in the real environments, we don't use these kind of devices because the hub devices are layer 1 devices. Because these kind of devices are just one collision domain. We have more collisions and errors when we use these kind of devices. So we mostly use switches instead of hub devices. But for the interview or exam, we should know about the hub devices, how they work, and what are the advantages or disadvantages about the collision domain, the type of devices, and everything that you can see here. For the switches, by default, the switches are layer 2 devices. So instead of hub devices or instead of repeaters, we use switches, and we connect the access point and devices, any kind of devices, to the switches. These layer 2 devices do packet switching, and switches use packet switching to forward data. Switches examine the destination MAC address of incoming frames and forward them only to the specific device to which the frame is addressed. So we should know about the collision domains, because each port on a switch is its own collision domain. It's very important. So we have less collisions, less errors. We should know about the address learning, about the MAC address table, about the broadcast, the full duplex communication, because we are using the switches, so we have full duplex communication, higher throughput or bandwidth, and these kind of devices are manageable, and it can support VLAN, PoE, link aggregation, Ether channel. They are reliable and scalable, obviously. And about the IPv4 and subnets, we will talk about the subnetting and IPv4 v6 addressing and routing later, but for now we are going to configure two different subnets and configure IP address and have connectivity. So you can have more information here about the MAC address or media access control. Address is a unique identifier assigned to a network interface controller, or NIC, for communications on a network. We have unique address, multicast address, and broadcast address. We should know about them, and the lengths of the MAC address, and the information related to that. Also about the ARP, or Address Resolution Protocol, which is very important too, because ARP is a network protocol used to map an IP address to a physical MAC address on a local network. And ARP is essential for communication between devices on the same network. It allows devices to discover each other's hardware addresses. So we should know about ARP request, ARP reply, ARP table, and ARP cache, because when we are configuring and troubleshooting, we should know about every different kind of protocols and how to troubleshoot, how end devices, switches communicate with each other, and about the gateway. In the context of IP configuration, a gateway serves as an essential component for network communication. When you are configuring IP addresses on end devices, you have to configure IP address and IP gateway or default gateway on any kind of devices. Because when you send traffic out of your network, this kind of devices and devices should send the traffic to the gateway to reach the other side of the network, to reach the internet. So we should know about the definition, the gateway, IP routing, routing tables, internet connectivity. If we are configuring DHCP for the configuration side, we should configure IP address, the pool, and the gateway. In the different chapters, we will talk about the DHCP and the configurations and how to configure the routers and switches to assign IP addresses to the devices. But we should know that the default gateway is very important when we are configuring the end devices, the switches, and the DHCP configurations on the routers and on the other devices too. For the lab and for the configuration, we have these kind of steps. In Packet Tracer, we should configure the PC and the laptop for the IP connectivity. In Packet Tracer, it's very easy. If you click here, exactly in this tab, desktop and command prompts, you can type ipconfig to check the IP configuration. So as you can see, we have no IP address configured, no default gateway. So we go to the IP configurations here and configure the IP address. For this network, we should configure 192.168.11 and the first IP address, which is 1. The subnet mask is 255.255.255.0. It means that we have 254 addresses. The gateway here isn't important because we don't have any router or layer 3 switch to configure, so it's not important. After the configuration, if you go to the command prompt and you type the ipconfig commands, you can see that we have the IP configuration. So in Windows operating systems, if you open the command prompts and type the ipconfig, you can see the IP configurations like this. For the operating systems like Linux, the command is different. You should type ifconfig. Okay, for the other device like this, we go to the command prompts here exactly. It's Windows ipconfig, and IP configuration here we type 11.2, subnet mask like this, and we go to command prompts and type ipconfig, and we can ping IP address 192.168.11.2, which is my own IP address. The connectivity is okay because my interface is up, obviously, but we should check the other side, which is 192.168.11.1. And as you can see, we have the connectivity from laptop to the PC. So the connectivity is exactly from the laptop to the PC, so it can reach the PC and there is no problem. This side is the same, and we should configure 192.168.13.1. subnet is default. Check the configuration. It's okay. And here, desktop configuration 192.168.13.2, default subnet mask, and check the connectivity, ipconfig, and you can check the connectivity from laptop to the PC. Okay, the connectivity is okay and we have no problem. Okay, go back to the lab file here. We have configured the devices and we check the connectivity in subnets A and subnets B, but subnet A, devices have no connectivity with devices in subnet B. We should check that. It means that if we are checking the connectivity from this device from in the same subnet, we have the connectivity obviously because it's in the same subnet. But if we are sending traffic from the subnet B to the subnet A, we cannot do that because it's different. From subnet B to subnet A, we have no connectivity. And obviously from subnet A to subnet B, we cannot send traffic. So these devices from subnet A to subnet B cannot send traffic, or they cannot communicate with each other. If they want to send traffic to each other, they should send the packets to a layer 3 device, and then from that kind of layer 3 device like router or layer 3 switch, that kind of device can do routing so they can reach each other. From this command prompt, we check the IP configuration. We can send traffic to the same subnet, but if we ping the other side, for example 11.1, there is no connectivity obviously, or the other device, there is no connectivity. Okay, now we should check the MAC address table on switch. When you send traffic from any devices in the network to the other side, or when you send traffic like broadcast, the devices send the traffic, so the switches learn the MAC address table. So on the devices like the switches, if you check the MAC address table, you will see the MAC address that the switches learned from the traffic that they get on the ports connected to the end devices or the hub or the other devices like the switches or routers. So we can check the MAC address table on this on the switches, obviously. Let's see how we can check it. You can click on the switch, and here we have a switch like this, and go to the CLI or command line of the switch, and we can enter, and then we can type the show MAC address table and enter. We cannot see any MAC addresses here because there is no traffic between the subnets A to subnets B, so there is no MAC addresses here. We just connected another hub and PC for this network and for this subnet, and I want to configure this PC, and you can see that we have no IP configuration, but here I configure 192.168.11.3 and default subnet mask, and after that go to configuration and check IP configuration. And because we are configuring IP in the subnet A, I can ping 192.168.11.1 and 11.2. So in the same subnet, there is no problem here. And again, we go to the switch, and here we check the MAC address table with this command. I should say that just for now, we are not configuring any kind of configuration on the Cisco switch, because later on the other parts and courses and chapters we will talk about everything related to the Cisco configurations. But for now we are just checking the MAC address table, and this command is related to that. Show MAC address table, and if we check the MAC address table, we can see that we get the traffic from the port fast Ethernet 01. We get traffic from these two devices, the frames. We get the frames, so the MAC address table learns that the MAC addresses are from this port, and from this port, which is fast Ethernet 3, we get the traffic from this one. So if we check the MAC address table, we can see 3 different MAC addresses from 2 different ports. As we can have connectivity in the same subnets from PC3 to PC0 and laptop 0 here, we have the connectivity, and the switch can learn the MAC address. So for subnets A and subnet B, you can add PC and connect to the switch, or connect to hub and then connect to the switch, and configure IP address in the same subnet for subnets A and subnet B, and configure the IP address and verify the configuration. And with the ICMP packets, with the ping command, you can check the configuration and send some packets and check the MAC address table like this. And finally here, we should clear ARP cache on end devices. It means that, for example, here on PC 0, we go to the command prompt and we check the configuration like this, and to check the ARP cache on end devices like the Windows operating systems, we can type ARP-A like this, and we can see that for IP addresses we have different MAC addresses that with the ARP protocol we learn the MAC addresses. For IP address 192.168.11.3, we learn the MAC addresses related to that end devices. So we are verifying right now with ARP-A. When you need to refresh the ARP table or clear the ARP table, you should type ARP-D to delete the table or remove everything. And if you type ARP-A, there is no entry here. When the communication happens again, the end device learns the MAC addresses and everything. So I pinged the other side like 11.2 or 11.3, and then again ARP-A to check, and you can see that we have the MAC addresses of the other side. Just one more command. For example, here on PC1, command prompts, if you need to check the configuration and have more information, you can type ipconfig/all, and you get more information related to the NIC or network interface card, information related to the IP address, gateway, DNS, if we get the IP address from the DHCP server, or we configure the interface, and the MAC address, and everything like that. If we have Wi-Fi and Wi-Fi NIC connected to the copper cable, and also the Wi-Fi, the Bluetooth connections, and different kind of network interface cards, everything you can see, all of them with the IP address, the MAC addresses, with this command. We have all of the files here. lab Cisco Packet Tracer lab template file and Cisco Packet Tracer lab completed file, and all of the commands here. You can see that for the Windows commands, ipconfig arp-a, arp-d, ipconfig/all. If you are using Linux, you can check with ifconfig, and the Cisco command show MAC address table. Thank you for listening.